All right, good morning, everybody. Thank you for joining us. Welcome to our Tackling the Labor Shortage with Integrated Automation event. My name is Ken Sissel with CR Onsrud. We are a manufacturer of industrial CNC routers and machining centers. We also have Ralph Butler and Shane Governor of Microvellum, developer of CAD CAM SIM solutions. And we have Roman Benkert of Barbaric. They manufacture material handling and storage solutions. All right, so a brief overview of the event. Basically, I'm going to go over why we're here today and give you some things to consider when it comes to automation. Then we'll have a live demo on one of the several options that we have to offer you. Then Ralph will talk about some of the programs that were used for the demo. Then we'll answer any questions that you may have. Feel free to ask here in person or online. You can unmute and ask your question, and we'll do the best to answer it for you. Then I'll jump back in and talk about some additional Onsrud options and solutions that we offer. And then Roman will talk about some additional Barbaric solutions that they have to offer. And then Ralph will finish up with additional Microvellum solutions that they can offer you, show you how powerful their software is. And then we'll wrap things up. So let's get started in just a second. Why we're here? Well, there is a labor shortage, and we're hearing it every day through the media, through our customers, and even friends. Recently, I was with a group of friends at a neighbor's house, and we were talking about how you go to the restaurants and you see the sign on the window and it says, sorry for the slow service, you know, we're short, or they're just closed for the day because they don't have enough staff. And when you are there, it's not that they're not busy, because you see the bags of food going to the front to the delivery drivers. So the kitchens are busy. They just don't have the staff to serve you. So there's a labor shortage that we're hearing about it. Our manufacturers are hearing about it. I even experienced it Monday checking in my hotel room. I got to my room, opened the door, and it was not cleaned. So I had to go back and get a different room. So it's everywhere. Manufacturers are seeing it. And it used to be we were looking for people with some sort of skill, somebody who could at least read a measuring tape. And that's not the case anymore. We're just trying to find bodies, and it's hard to find bodies. So hopefully we're going to give you some ideas and solutions that you can that'll help you tackle this labor shortage. So let's talk about some things to consider when it comes to automation. There's been plenty of studies on the time involved into making a product, and it's divided into three areas: value added, non-value added, and waste. And you can notice that the value added is very little when you consider what is involved in making a product. And today we're going to talk about the non-value added time, the things that you don't get paid for. They are necessary, but you don't get paid for them. For example, calculating how much material you need, ordering the material, you don't get paid for that. You don't get paid for programming or setting up the machine, or even loading and unloading the material. You don't get paid for any of that. You have to do it, but you don't get paid for it. What you do get paid for is actually doing something to the part, whether it's machining, drilling, edge banding, painting, assembly. Actually doing something to it is what you get paid for. So we're going to show you some software that can handle the material calculations, show you material handling equipment that can do that quickly, as well as machines that can keep up and produce products much faster for you. So talking about that non-value added time, we recently did a study on one of our smaller entry-level machines, and at the end of the program, when the machine was done cutting, we started the timer and timed from when the operator unloaded all the parts, unloaded all the scrap, cleaned off the table, loaded the next sheet, and then hit cycle start on that program. We stopped the watch. It was an average of about 2.5 minutes. Now that's pretty conservative because one, we're standing there with the timer, so they're going at a pretty good pace. We see much worse in the field when nobody's watching and stuff like that. But for today, we'll just stick with the 2.5 minutes of a unload, load, cycle start time. Then we did the same study on the same model machine with just a simple offload system. And basically, at the end of the program, the machine automatically offloads all the parts and scrap onto an offload table and simultaneously cleans the table, picks up all the dust and debris, sucks it off the table. So it allows just the operator just to load the next sheet and hit cycle start. And that was an average time of less than a minute. So much more value added time, and we'll show that here. So if we took just a 5-minute runtime, a program that took 5 minutes to cut parts out, and then we added the 2.5 minutes of load, unload, in an 8-hour shift, you'd get about 64 sheets. And the big thing to notice here is 64 times 2.5 gives you over 2.5 hours of that non-value added time, that loading and unloading, not doing anything. You got to do it, but not doing anything. And then comparing to the automated system, just automatically pushing off the parts, we increased our sheets, number of sheets, to 80, and we decreased the percentage of non-value added time. So what's the cost of that non-value added time? So if you look at this over 2.5 hours of this, remember, you're not getting paid for it, but your operator is getting paid for it. So just keep that in mind when you think of things like that. The other thing in automation is there's a misconception that you need high volume, high throughput. I got to do thousands of parts to be able to justify automation. And that's just not always the case. Automation doesn't always necessarily mean more parts. It just means more value quicker. We have several customers that, for Greg, for example, here, he's a one-man shop doing everything. He's doing the programming, the machining, the edge banding, assembly, and even going to his customers and installing them. And he was working 14 to 18 hours a day. He just couldn't keep up and decided to invest in an entry-level offload system that we have to offer. And now he only runs his machine a few hours a day. So he runs it in the morning, then he spends the rest of the time edge banding, assembly, and then on Thursdays and Fridays, he's not even running it. He's at his customers installing the cabinets and stuff. So if you kind of consider that value added time, do you want to make $10 in 3 minutes or $10 in 1 minute? You know, reduce that time, make more money per hour, get the most out of it. The other thing we're seeing is higher wages. People are wanting more money to come back to work. They're wanting more benefits, and they're not even trained. They're not even skilled. So not only do you have to pay them more, they're also expecting you to train them to do their job. And there's a delay in your growth. You hired them to get more throughput, but you got to train them first before you can realize that addition. And some would argue that there's actually a reduction in throughput because whoever's training them is not producing at the level they would be. So we're going to show you some areas in automation that can help. And some of that is simplification. Automation can equal simplification. Recently, my son came home from college and he was talking about these AI essay writers, artificial intelligence writers. So if you have an essay that you have to do, all you do is tell it the topic or subject, you give it a few key points, and then you tell it how many words the essay has to be, 300, 600, 1,000, and it will automatically write the essay for you. Super easy. So you don't need to be this skilled writer. I don't know about you, but I remember in college spending hours trying to put together my essay that's due the next day. But this will spit it out automatically. And I couldn't believe it, but it does work. It worked great for this presentation. So it's about simplifying the process. Just kidding. It's about simplifying the process. You know, having software that's easier and quicker to learn, having a machine that's easy to set up and quick to set up, and providing effortless material handling, which is much safer and faster and again, reduces the skilled labor. Basically, kind of turning them into button pushers is what you could be looking for. Now, I know I talked about you don't necessarily need high volume to justify automation. Well, there is a demand right now for more. Everybody wants more, faster, faster, faster. And we can help you with that demand in several areas with automation, software, and equipment. And when it comes to high demand, high volume, we get asked a lot of times, how fast is your machine? And everybody says, oh, we can do 2,000 inches a minute. And it's not necessarily how fast the machine is, it's how fast can it get there. Every machine can do 2,000 inches a minute, maybe even more, but how fast can it get there? Can it even get to the 2,000 inches a minute? And I'll give you a relation. So my wife's Prius, it'll do 93 miles an hour. Like, that's it. It'll do 93 miles an hour. Takes a while, but that doesn't mean I'm going to take it to the drag strip, right? Because that acceleration is just not there. It can do 93, just takes a while. And that's the same when I'd like you to consider when you're looking at equipment too. What's that 0 to 60 time? What's that 0 to 2,000 inches a minute? That's where we can help you with the throughput and the high demand, high volume with these performance-driven products. Faster software, faster material handling, and faster equipment. So back to the non-value added time. Remember, this is what we're looking at, is reducing that non-value added time, the stuff that you're not getting paid for. And if we bring it all together and we look at programming time, machine setup, material handling, machining, and even unloading material, if we can reduce each of those areas, you get more time to add value. So now we're going to do the live demo here. I'll briefly go over the demo. So first you're going to see the LCV loader here. It's going to pick up material and set it on our pre-stage table. And the pre-stage table helps with two things. One, it creates a buffer between the machine and the loading system. What you don't want is the machine waiting on the loader, and you don't want the loader waiting on the machine. So we have a pre-stage table here, and that creates the buffer. The other advantage to having a pre-stage table is we could have a pre-marking, pre-labeling station right here that would pre-mark or pre-label the material before it goes into machining, and I'll get into that a little bit later in the day. Next, we have our RH series roller hold down machine. It's a moving table, and I'll talk about some of the benefits of that as well. And then after the sheet is cut, it will be pushed off to the offload table, and the parts will be picked up by the NST picker and stack them on a pallet. And when that's finished, the scrap pusher will push all the scrap into a bin. So feel free to get up and watch the demo. So on this model, you notice this is a moving table. The table is moving back and forth. Advantage of a moving table versus a gantry is if you think of a gantry machine, you have all that mass that you have to get up to that cutting speed, let's say the 2000. You have all that mass that you got to get from 0 up to the cutting speed and then back down to make the next turn. With a moving table, you're only moving the material and the table, so much higher acceleration because much less weight. You probably also are wondering what the rollers are on the table. We have clients that cut warped material, such as plywood. Well, the rollers help hold the material flat during the cutting process, warped material. As well as we have clients that cut stacked material, multiple layers of a material. So the vacuum table will hold the bottom sheet, and then the rollers will hold the sheets that are stacked on top of that. Now, it'll be finishing here in just a second. Now, the LCV can pick up a variety of material sizes from 2 foot by 7 foot up to 7 foot by 13.5 feet, weighing 440 pounds. This is a single bunk system. It can come in multiple bunks as well. The next sheet is queued up. It's going to be finishing up here in just a second. There we go. So the pusher is coming down. The pusher is what's going to be pushing off the material and cleaning the table. So it's going to go grab the offload table, and then the pusher will come down and you'll see it pushing the material off onto the offload table and sucking all the dust and debris off of the table. So in the backside here, you can see the clean table. And then the pre-stage table is going to push that next sheet onto the machine. And then it's going to come forward and be placed under the NST picker. And I'm going to hand this off to Roman to talk a little bit about the NST picker.
So once this nest has been pushed off on the offloading table, we receive a file transfer of the nests that's on the offloading table. And then you can see, if you look at the top, you can see a camera mounted on top of our system. The camera takes a picture of the nest, of the actual nest that's been pushed off, and analyzes each part. Most of the parts tend to shift when they get pushed off, so they're not in the exact location as the file that we get transferred. So as we analyze each part, we know the exact location. We can still pick it up centered, ensure that it gets stacked off in an orderly fashion without any twists or rotations in the parts. And the NST can be programmed with a variety of sorting criteria or stacking criteria. You can have it sort by part size. You can have it sort by job order. You can have waste pieces that you want to use for further processing on a separate pallet. What we can also do, if you prefer to have a belt integrated, you can have parts stacked directly onto a belt and send it down to whatever next process you have going on in your shop. And once the NST has finished picking and stacking all the parts, we will send a release signal to the CNC that we're ready to go, the table's clear, and push all the scrap into the bin located at the end of the table.
So there it just cleaned off the offload table. That can go into a bin or a hopper or a scrap conveyor, anything like that. Now, somebody had asked about pushing off the material. If you have high cosmetic material that might get scratched, we could pick this right off the table instead of pushing the parts off onto the offload table. All right, so while that's finishing, we can work our way back over to the monitor and we'll have Ralph talk about the programming that went into these nests for the demo.
Hello, my name is Ralph Butler. I'm here with Shane Governor from Microvellum. What we do at Microvellum is develop software influenced by companies just like yours to help streamline your design, engineering, and manufacturing processes. Helps you grow your company confidently, help you streamline those processes, getting rid of redundant activity, eliminating what Ken was talking about is the non-value added activities or processes that you have. That's the whole idea. Streamline, standardization, automation, they all go together, okay? So in Microvellum, we make more than just boxes. We do fixtures, all sorts of things throughout the millwork shop. In today's example, when you looked at the process that just ran, that code for the Barbrick and the Onsrud router were created through a process, one of the processes or one of the methods we have of putting data into manufacturing, and it's through the 2D drafting or submittal process. So I used that to create the code and the parts list and material takeoff and all of that. Once that stuff is created and submitted, drawings are approved, you can go ahead and create a work order. A work order is a batch of work. It's the work in progress. It's how you group product together to go into the shop to manufacture, in case anyone's unfamiliar. I don't want to say anything that's a Microvellum term that you might not understand, so I'm sure everybody knows what a work order is, though. Once this work order is created, you can see there's a completely cut listed part list. We can assign any of the processing stations that you have for your shop. Onsrud is here. We used that as a nested-based router and assigned it out here to all the components. Once we process it, we're generating the nests and the code to go to the machine to route everything out. And you can see that we can create reports that can be scanned if you're doing a manual thing. You can either search for your files, scan for them on a barcode, pull it up and run it. But in today's situation, we actually created files that went out that told the Barbrick system what was needed to be loaded and what was needed to be done with these parts, what the parts were, their description, and all of that. That's what fed this information into the machine. So we're going to have additional comments, but right now we'd like to stop and see if there's any questions about anything that you've seen so far. We also have online people that are watching this. We'll give a few seconds for somebody to ask a question so we can make sure we answer everyone's questions.
Yeah, and if you want to ask a question, just unmute, ask your question, and again, we'll answer it the best we can. Did get an online question. Yes, we do provide moving gantry machines as well, not just the roller hold down or moving table machines.
We had a question come in through the chat.
I was asking about if the machine would tell how much waste is coming off per sheet so we can track that.
That would be in the software side of it. So the software can manage and tell you the material yield. And then we have a reporting software called Onsrud that Onsrud provides that can capture that data and show you your material yield, your average yield and stuff like that. Jeff, go ahead.
Yeah, there was a question that came in via the chat. How easy can I change where the NST offloads to? Say, can I have a conveyor or a cart, or I want to change my pallets?
I'm sorry. Can you repeat that question, please?
How easy is it to change the offload pallets for the NST?
Can you go to pallets and carts?
So yes, that's pretty straightforward. So when you initially program the NST, or if you want to make a change down the road, you just in the software you set up the pallets or a cart. The only thing that you might have to change then is the location, and it's pretty straightforward. You can just enter the size of the cart or the pallet, and then we can have the manipulator head come down, point at the center of the cart or pallet. You can set it up that way, mark it on the floor wherever you need to set that up, adjust the height if it needs to be, the initial height where we stack on, save those parameters, and you're good to go.
Any additional questions?
All right, we'll keep rolling. Thanks, Ralph. All right, now I'll talk about some other Onsrud equipment solutions. At Onsrud, we manufacture a variety of machines. So from 4x8 small machines all the way up to machines just about as big as this room here. We sell into the marine industry, RV industry, aerospace industry. So like the machine that's about as big as this room, that's for large boat molds for boat hulls and stuff, and even aerospace components. But we'll kind of stay on topic today and talk about panel processing and automation. So if we look at the offload system, of course, you've got the manual offload where somebody's cleaning it manually, but we also have the pusher sweeper system, which you saw here, which pushes the material off and cleans the table. And we can push that off onto two different options. One is what we call a static table, which you saw over there, but we also have a conveyor table right here that conveys the material to the operator. And basically they're just standing at the end of the conveyor, catching parts and stacking them or moving them on to the next process. And then of course the other method, which you saw here, was the NST picker, which picks off parts directly from the table. And then as far as loading, of course you got manual load, somebody loading it, but we also have vacuum lift options. Those are vacuum lift options usually under a crane or jib crane, where the operator can pick up the sheet, set it on the table without handling it themselves. Much safer and much more ergonomic. We actually have those here that we can give you a demonstration later if you guys would like to see it. For smaller shops or single bunk shops, if you will, we have a scissor lift option where you put your bunk of material on this scissor lift, and after each sheet is pulled off of that bunk, the scissor lift raises and presents the next sheet. We also have the overhead lift system, like you saw here, the LCV. And again, this was just a single bunk station. You can see up there, the rails can be added. They could add rails to make it longer and be a multi retrieval system, mobile bunk retrieval system, and we can set it up to go either way. And Roman will go into that stuff in just a little bit, as well as full material storage and retrieval systems. For floor space requirements, if you do not have the floor space for a linear system, we also have a cross table system, which will go across the table instead of lengthwise. I think this one's just under 50 feet. Not everybody can do that, so we have one that sets across the table and reduces the footprint size. Same with this loader. We could rotate it 90 degrees and have the material right next to the machine and load on there. So a couple options there when it comes to floor space. And of course, we have large format automation. This machine in particular is 8 foot wide by 30 foot long. There's the pusher sweeper there. That's for large industrial SIP panels in the construction industry, where they have OSB with foam in the middle. So that machine will automatically load that big panel, cut it out, and then push it off and clean the table. So we do have large format automation as well. And then as I mentioned earlier, above the pre-stage table, we could do pre-labeling or part marking. And we can also do that right over our scissor lift option that I showed just a minute ago. And we could print labels right onto each individual part, which identifies the part or job. And we can also identify and tell the operator what the next operation is, if it's edge banding, hardware insertion, or straight to assembly. And for example, on edge banding, we can even print on the label what sides of the part need to be edge banded. So that's pre-labeling. We can also do inkjet marking directly on top of the part, on top of the material. We can use a variety of inks, some that are permanent or some that could be wiped off with alcohol or something like that. So we can actually print directly to the material. And then we also have painting. We have clients that need to paint layout lines or weld lines, bend lines, or do some sort of shape. One of our clients, they have 6 different colors that they use for layout in the construction industry. So they use blue for cold water, red for hot water, yellow for communication, white, black for power, stuff like that. So we can actually paint on top of the parts as well. We can also do, again, automation, robot tending, where we have robots loading material and then unloading components. We've even set up a few where the robot will load the machine, it'll cut components out, take those components, put it in a fixture, and then another robot will drill screws automatically into that fixture, into the part, and you have a completed part coming out. Another feature we talk about again, and this is that value-added time, keeping that spindle running, cutting, making money. We have an option on our twin table machines, twin moving table machines that we call pendulum processing. So here you see on this machine 2 tables, and while the machine is cutting on this table, your operator is loading, unloading on this table. And when this one's finished, they switch in and out so that spindle will come over here, start cutting on this table, while the operator is loading and unloading the other table. Pendulum processing, keeping that spindle running, making the value-added time. We can also do this on our long gantry machines. This is a 20-foot gantry machine here. So you load the 8-foot sheet up here at front, in the front. The gantry will start cutting on that one. Your operator will load the next 8-foot sheet at the back of the table. And then the gantry is what's doing the pendulum processing. So we can do that on moving table format and gantry format. Then on these twin table machines, we have another option called dual process technology. And we can actually put a second head on this machine and cut 2 parts at the same time on either table. Or we could actually unsynchronize the spindles, and we could cut 2 completely different programs simultaneously on the machine. So this spindle could be on this table cutting circles. This spindle could be on this table cutting squares. 2 completely different programs, again, getting more output, more value per hour. We can also, on our gantry machines, add a second gantry that can work with each other, or again, work on two different programs at the same time. We also can do this dual process technology on our 5-axis machines. We have a lot of clients with 5-axis parts that have to do machining on the top and then flip that part over and do machining on the side. So you could have your top side fixture on one table and your bottom side fixture on the next table, and do that dual process technology. And as I mentioned earlier about the material yield and tracking, we have our OSync live machine monitoring that can track your OEE, your overall equipment efficiency, how many parts you cut that day, what was the time between each program, etc., and provide that data, as well as maintenance information as well, servo loads, temperatures, and stuff like that that helps the maintenance department. Any questions on the Onsrud offerings? So the question was, will the OSync software call his cell phone and notify him? Yes, you can actually have it notify you via text, email. You can set it for certain hours. You might not want the text at 2 in the morning. You want your maintenance guy to get that one. So you can set who gets it and when they get it, and yeah, a variety of functions and what levels. So you can have levels of alarms. You know, if you have low pressure alarm or something simple like that, you might not want that one at 2 in the morning, but something like that. So yes, great question. Any others?
One came in online. Can you add a printer to the system you're showing behind you, and if so, where?
Say that again, Jeff.
Can you add a printer to the system behind you? And
Yes.
if so, where?
Yeah, it would go right above the pre-stage table. So it's a 2-axis machine essentially that would slide under here, and the arm would be right above this table and can print on that sheet that's in the queue. Looking good? All right. Next we have Roman here.
Thank you, Ken. Hey, I'm Roman Bencard. I'm a sales and product manager with Barbrick North America. I want to show you some Barbrick solutions for material handling and sorting paints that we offer. So I want to really quick reiterate on the two machines that you saw on the live demo, our LCV and NST system. The LCV system is a loading system. We can set this up in a multitude of ways. You can have numerous amount of loading bunks oriented in any which way that fits in your shop. Can be perpendicular, parallel, or linear to your system. And here in that graphic, you even see that we can locate them on both sides of the machine as well. And we can also integrate a 90-degree turning function to be able to turn that pallet as we load it onto the in-feed table. With that system, Ken mentioned it briefly earlier, also has an automatic length adjustment or size adjustment, so we can handle pretty much any panel size that you encounter in your shop. The NST, nesting picker, we can handle up to 130 pounds per part. Parts as small as about 3 to 11 inches, and parts as large as over 4 by 9 feet. So here in this graphic or in this picture, you can see a couple of stacks being stacked off. There's numerous criteria that we can program to sort material as it is being stacked or offloaded. And mentioned that briefly earlier during the demo that we use that automatic part detection with that camera, which also helps create nice and even stacks and takes into account any twisted or rotated parts. Some more on that part detection. So here you can see the nest that's being sent from the CNC. So that's the actual nest, but as it's getting pushed off, you see some of these parts get rotated. So it's essential that we adjust that during offloading. So a lot of you might be familiar with the robotic systems that you use for unloading and stacking. So one huge advantage that we have with our system, all we really need is the file being sent on from the CNC, which is already in existence. So anytime you introduce a new nest, our machine does not have to be trained. As to the robots in the industry, you have to train them for every new nest that you introduce. We also, and again, all of this is fully automatic, both the LCV and NST, without any operator intervention, eliminating the labor that you need to use for those. Storage and retrieval systems. The CSF Professional. This is also a great feature where you can store all of your inventory within one system. You essentially just need one operator to load stacks of material in the loading bunks. And then you can simply send from anywhere in your shop, from your office, you can send work orders to our system. And then it automatically sends these jobs to the CNC or saw. We can integrate multiple machines and works off that job order by itself. Here you can see a layout where we have a system that's actually in place at a customer with a storage retrieval system from Barbrick, an Onsrud CNC, and then also an optional NST, utilizing 3 loading bunks. And each of these loading bunks, you can also unload material if you ever needed material somewhere else in your shop where you didn't have a machine integrated. And our CSF Industrial, in essence, can do the same thing as the Professional, but it's just built more heavy duty to allow for larger and wider spans and hold even more inventory. And here you can see an example of the massive amount of inventory such a machine can hold. And the machine also comes in a multi-level, which has become very popular as floor space is becoming more and more expensive and limited. So if you have enough roof height, so as long as you have about 6 meters or 20 feet, we can already implement one of these systems. And the advantage is you have all the material storage on the top floor and keeping enough space on the bottom to still have machines on the bottom floor while still being able to feed machines directly from the top. So it's very space saving, efficient in that way. And here you can see an example. We utilize a long lifting arm to be able to feed machines on the bottom of the storage retrieval system. Another solution that we offer is our PBX buffer and storage system. So as the machine already says, this system buffers and sorts material for you automatically. I think everybody may have run into the issue of having materials floating around the shop as you're waiting on your machines to complete a job order. Sometimes material gets lost or damaged. So with this solution, here you can see a layout of you have this cube where you store all the parts, and then there's also again various criteria that we can sort by. Usually most of our customers that have implemented these systems, they sort by job order. So they wait until one job has been completed, from the cutting process, for example, and then they wait until they have all the parts in here in the storage system, in the PBF buffer, ready to go on to the next process. So they're already all sorted for you, stored in one place. You have access to them at any given time. And that's also very customizable. If you need more storage space, we can add additional cubes for more storage. And then here you can see 2 manipulators. And that just depends on the cycle times that you need to achieve, how much material we need to move a minute. And we also offer return systems. Again, here the great advantage is on a conventional edge banding machine, you have to have at least 2, if not 3 people to operate that machine for returning parts. And so here that's automated, and you can reduce the staff to one operator operating an edge bander. Here you can see the compact, which utilizes a cross conveyor to return parts. And then we also have an RTS Professional, which utilizes a vacuum head, which the advantage here is you can also turn parts as you get them returned, and implemented automatic stacking after you're done edging the product. Here you can see that the RTS Industrial, that's a more heavy-duty machine again that handles up to 220-pound parts and even larger parts. But here in this layout, you can also see stacks where finished parts get automatically stacked on pallets. Again, you can also integrate conveyors if you prefer to have the finished part conveyed to the next process in your shop. And these machines can also be built as a 3-axis machine, where it provides you with even more pallet space. And again, here we can also integrate sorting criteria to help you stay organized in your shop. I want to briefly touch on our software. So Part Production Live, for example, this is something we would use if we integrate a PBX buffer storage system. Up here, you just have detailed information about the production and handling. And then on the lower part, you actually have an overview of all the systems integrated in here. And you can see where each part is at any given time in your shop while it's being processed. So it just gives you an intelligent, planned overview. Even if you in the office, you don't want to check machine status and see where everything is, you can just take a peek at that. The majority of our machines also come with a touch screen, and that's just for ease of operation. You know, if you want to input something or just select a certain stack, you can just do it by touch of the screen. And then our software, I think we're proud to say that it is very user-friendly, very intuitive. We also offer bar break events, which is similar to what Onsrud offers, where you can have error codes sent via email. And you can also set what types of messages to be sent to where. And also great features, the Bar Break Live. So you can have on any mobile device from anywhere in the world, you can look in, see live machine status, online monitoring of your machine. And that's included standard in the software. And then want to briefly touch on our manual lifters. This doesn't completely eliminate the operator, but again, if you're handling larger panels, you need at least 2 people to handle those. And then lifting panels all day, that becomes very straining. So this is just a very ergonomic way of handling panels. You can use that to load machines. And we have a couple on display here in the shop, so if you're interested in that, I got my colleague Ryan Beester here today, who's the expert on manual lifters. Feel free to approach him and ask him any questions about those. And does anybody have any questions? I think we'll just wait a brief moment to see if the online audience has any questions. So yeah, if not, I think we're going to keep the show running, and I'll pass it back to Ralph for deeper dive into microvalve.
Thanks a lot, Roman. Appreciate it. So we're going to do a little deeper dive into some of the products and processes that we offer. And there's 3 ways I want to discuss today or talk about today that give you options for how you can enter data into the manufacturing environment. Initially, you know, I told you earlier that we use the drafting process to generate the data to run here. But we have other methods. Order entry. Let's say you've got an online or you've got a store somewhere at a storefront with display of your product, and someone comes in and makes an order. The salesperson creates an order, faxes it in to the manufacturing center. You can enter these things in with data entry, manual data entry. Perhaps you have product line that you have customers that know what your products are and they just phone it in. I need this, I need that. So we have customers that actually do that. Another method is XML import. This is more automated without having the labor of creating a project and importing or bringing in the products into the list like you would in order entry. Third-party software such as online sales, you can publish your libraries, many people do, to online stores. When the order is created, an XML file can be used as a file format that can be used and exported from that third-party software. We can import that. That file will automatically generate a project and a product list that can then be processed and sent out to the shop floor. A further automation of this is employing the MV server, which is a faceless toolbox-like application that we used for the drafting and all, and for the order entry, that sits on the server, and it detects when an XML file is imported, and automatically creates the project and the work order and sends it out to the shop floor. So there's no intervention by the engineering team, and it just automatically, when it comes in, just runs right out, further reducing labor and that non-value add activity that you're engaging in every time you create a project. So again, today we talked about the submittal drawing process. I'm going to show you some of that in a video that's coming up. I'm going to talk about it. The method that we use for today's example allows you to create 2D drawings for submittal. We have tools for creating these and automating that, and it's in the AutoCAD environment. It'll give you the annotations and the details that you want. You don't have to have the AutoCAD capability that you would to just simply draw in AutoCAD. And there's a lot that goes on behind the scenes, as you'll see in a little bit. I'm going to have to hit start. Okay, so 2D drafting. Thanks, Shane. I couldn't do anything without Shane, I'm telling you. So here we created a model. We modeled the room. Let's say this is a break room run of cabinets. Keep it simple just to show the process. When this was drawn, the 2D annotations came in automatically. But what I'm going to do is I'm going to elevate and I'm going to create elevations and plan views of this model of this room, this break room run of cabinets. You can see that I'm telling the program what to draw and where to draw it. I'm not drawing. I used to do that for a long time before I had microvellum years ago. And it's a labor-intensive process. It is an overhead that costs everybody that has to do this a lot of money. And it's hard to find trained people that can do it. And even if you do find them, it takes a tremendous amount of time. This is automatically doing this. And what you can't see at this time is that the data behind these products is already in the project. I'm going to cut a section and everything, and we'll talk about the publishing in a second. But I don't have to have the ability to draw line for line or insert blocks. The program is doing that for me, and what you see is what you get. The sections, the elevations, the plan views, they directly represent the product because the data is telling the program what to draw. This is going from information to objects, and in a little bit we're going to show you how to go from an object to information. So we work with many of the AutoCAD functions such as Sheet Set Manager and others, annotative dimensioning and all that. And so you can publish these drawings across multiple DWG files really easy. Getting into the solid modeling, this is where we would go in and create an object to create data for manufacturing. So we can import solids from other programs such as SolidWorks or Inventor. Once they come in, we can analyze them to create a cut listed product. But today, I'm going to draw this for you. I've actually sped this up a little bit with full disclosure. It's running at 1.5 the speed, so it's not that much faster, but I didn't want you to have to sit and watch me draw this table. So I created solids. This method would require you to have someone on staff that knows how to model in 3D or to import a 3D drawing. But if you're going to do this, there's another level of skill that you have to have. It's not hard to learn, but it is something that they have to know how to do. So I'm going to assemble these parts and pieces as solids once they're created. And then once that happens, I'm going to go ahead and assign these parts to layers. The program uses the layer name to create the name for the part. So I created a layer for each specific name type that I wanted for these components. You know, you don't want to send anything out to the shop that says part 1, part 2, part 3. It makes more sense if it says side, modesty panel, tabletop, that kind of stuff. So I assigned those layers to it, and then I can analyze it with the solid model analyzer. It recognizes the thickness of the parts. You have to draw within the constraints of the material that you have, width, length, and thickness. So it recognizes the thicknesses, gives me an opportunity to assign the material, and then I can, after its analyzation, I can simply set it down in the drawing. And it is a fully cut listed product. It's non-parametric, but it's a one-off product, and I don't need to write logic into a one-off product. Once that's done, I can actually go about sending it in as a work order. There's a couple of other things I wanted to show you. We can modify this product, add machining, and do other things to it simply by using a couple of tools. One of them, this first one, is the 2D editor. So what I'm going to do is draw the part in 2D, and I'm adding a macro in this instance that has a tool assigned to it and depth and that kind of thing. And what it's going to do is create a cutout in that solid. Now, you could have done that by using subtract or some other thing in the extrusion, but I just added this using the 2D part editor to create that cutout. Now I'm using the part properties, and what I'm going to do here is take some of the machining tokens that we have and assign it to the components. In this case, I'm joining the modesty panel to the two sides using associative dado. Once I know I have one, and filling in a couple of these parameters is not difficult. We can show you how to, we will train you how to do that. But once I have one correct, I'll associate a dado to the other end of the modesty panel, which will associate it to the other side, and so I have my joinery to join those together. I'm going to go back to the 2D part editor one more time. The last time I used a macro, this time I'm just going to draw AutoCAD lines and arcs. I'm just simply drawing in AutoCAD to create a tool path. So I created a lead in, I'm going to mirror it over there and put in a lead out, and then I'm going to create an arc. And this is going to be the path for the machine to run to cut the part. It could be a profiled bit, straight bit, whatever. It could be that I want to design a sculpted design on the side of an open tall cabinet. This is the same method you might use for that. So I've mirrored it to the other side, assigned the router. I can control my tool comp. What I see is what I'm going to get. So I can, the engineer who's working on this can actually see what's going to happen. The next method is extruded products. Okay, in the last one, I had to draw in 3D. In this one, I don't. I may not have anybody on staff that knows how to draw in 3D, but they can draw in 2D. Okay, so I can draw a section in 2D. They have to be drawn a specific way, closed polylines, but that's not difficult. Assign these components to what we call smart layers. The smart layers have properties that tell the program what to do with these parts when they extrude it. So I'll use the tool to create a product, and it'll be a new empty product. And then I'm going to use the tool to actually grab or capture this 2D drawing and all of its components. And the program automatically knows through the smart layers what to do with this. Now, in this example, I did not speed this up. This is running at 100% straight time, times one speed. And it's bringing in the machining and everything. So you can see, yes, this is a simplistic thing that I did. Well, it's not that simple, but you can see how quickly it works, how fast it creates a 3D solid. So we have all different types of products that are in here. I have these parts for the studs, but also have the parent. I can do things like change the spacing for the studs and so many other things that I can do here. How I navigate a corner and all that kind of thing. There are additional tools that we have under the extruded tools that will allow us to do other things to manipulate these parts. So I'm only going to show you a couple. I'll use one to erase an extra component, and I'll get another one over here. I'll erase this other double up support. And then I'll use move part command, and I'll just move this over a couple of inches. There's tons of others. We can do things like replace a part. I can modify this drawing, and when I do, it'll automatically update this drawing. So change the navigation of the countertops in the corners, whether I want them to be a certain distance before or after the corner. Now they're set at miter. But once I have this the way that I want it, I can save the product. Again, this is running at real time. When I go to save this product, all I have to do is go back to the tree view, pick the product, and save it. The idea here is to streamline the workflow, to get rid of things that just take up so much time, to make this as quick as possible. There's 105 parts in this wall. In this short amount of time, I was able to go from 2D drawing to a 3D solid to a cut listed product. And you're going to see in the spreadsheet in just a minute, there is a ton of data that's there. It's ready to be manufactured right now. I'll open it up in the edit design data, and you'll see the list of parts with all the names of the components, with the material assigned. The machining is in here, everything. This tool improves, and our customers that have it, this and the solid model analyzer, their productivity by about 70% or more. The drafting part for the 2D drawings, we can get as much as 35% improvement on the time. So then we'll go to work order processing. So in work order processing, just like today, to create this, I went to the break room drawing, and I'm going to come over here and I'm going to create a work order from the drawing by windowing or crossing over all the items and their item numbers. And it's going to create my work order that I can name any way I want. I can group products from other projects as well. If you have two small projects and you want to put them together, you can do that, or I can just do a single product. I'll process the work order, creates a database. I've got 92 cut listed parts within this product, these 8 products that are here, and there they are, with all of their materials, edge banding, and everything. I can assign them to a router or any other activity station or processing station that I have. And you can see out there that there are columns for each one of those, so it puts an X in each one. I can actually add multiple active or processing stations to individual parts. Once it's done processing, it's going to create the nest and many other things. These reports come with the program. You'll be able to print these out and scan them to execute on a router, or in today's case, we actually sent that data right to the Barbrick system to be picked and pushed and cut. So we'll even cut up the scrap and that kind of thing to go off at the end. The Barbrick information went straight out to a destination folder, just like the router information and everything else. The right data at the right time in the right place. You get all these reports that come with the program that are already there. If you need additional reports, we have a fully integrated report designer that you can use to create your own, or you can go paperless. It's totally up to you. Microvellum.com for more information. You can join up for our knowledge network. There's no charge, and it's open to the public. So I think at this time we're going to see if there's any other questions, or any questions about this in particular to start. Hank, I want to give you a mic.
We use a third-party program called WorkPlan for inventory tracking and all that.
Mm-hmm.
Will Microvellum integrate with that program in particular, or is it integratable to other third-party inventory
Absolutely. We integrate with other third-party software all the time, whether it's an ERP, MES system, order entry systems, just like others, that own the store. There's just tons of them that you can get. If they can output a file or take in a file such as XML, CSV, those types of things, we can. And we have an open database, so we don't lock people out. You can come in and mine data from our database even. So yeah, we can connect with that. Now, in some cases, I just want to say, sometimes it's a one-way communication. So I might send to you what's been consumed, and you can record that and handle that in your inventory system. Yes. Any other questions?
We had a question come in via the chat.
Okay.
What kind of training does Microvellum provide?
So with every software purchase that a new customer might purchase, we have integration. We'll help you install and set up the program. We connect to your machines. We do your post, and we test all that out. And we set up your data for your default joinery and that type of thing. So we want a functioning platform before we train you. But every single new customer gets training. It may be online, depending, or most of the time for people that are doing CNC manufacturing, it's going to be for on-site training. That'll be a 40-hour training, and we have follow-on post-go-live training. You can purchase training anytime you want, but basically, when you purchase the software, you have adequate training to get you up and going and on your way, and we don't just leave you alone to get that done. But yeah, we have training, and you can purchase it at any time. I hope that answers.
We had another online question. For the system behind you, if we already have a different CAD/CAM software and we don't use Microvellum, can we still use that system?
Absolutely. Yeah, we write to the thing. We've gone to the trouble to integrate and to work with Onsrud and Barbaric. I'm fairly sure that just about any CAD/CAM program that's out there could do it, but it needs to be tested. Okay. Thank you, Ken.
All right. Well, thank you very much for taking time out of your busy schedule. Hopefully, we were able to show you a brief insight of some of the solutions that we have to offer to help reduce that non-value added time and increase that value added time. So thank you very much for joining us.